Welcome back. We've now built a variety of models. But how do we actually measure their performance in a meaningful way? Today, we go beyond simple accuracy and learn about the essential evaluation metrics, precision and recall. The most intuitive metric is accuracy. What percentage of predictions did the model get right? But accuracy can be a trap. It's especially misleading when you have an imbalanced dataset. For example, if you're trying to detect credit card fraud, which is very rare, a model that predicts no fraud every single time could be 99.9% accurate, but it would be completely useless. This is why we need precision. Precision answers the question, out of all the times our model predicted positive, how many of those predictions were actually correct? Precision is about the quality of your positive predictions. You need high precision when the cost of a false positive is high. Think of a spam filter. You would hate for an important email to be wrongly sent to spam. The other side of the coin is recall. Recall answers the question, out of all the actual positive cases in the data, how many did our model successfully find? Recall is about the quantity or completeness of your positive predictions. You need high recall when the cost of a false negative is high. Think of a medical test for a serious disease. You absolutely cannot afford to miss a single patient who is actually sick. This leads to the fundamental trade-off in classification. You can't have it all. Tuning a model to have higher precision will almost always lower its recall, and vice versa. The right balance depends entirely on your specific use case. Are you more worried about false positives or false negatives? The answer to that question tells you which metric to focus on. And that's your essential toolkit for evaluating classification models. By understanding accuracy, precision, and recall, you can get a much deeper and more honest picture of your model's performance. But where do these numbers actually come from? In our next lesson, we will explore the simple tool that makes calculating them easy, the confusion matrix.